Here we have the electromagnetic spectrum. Remember that this spectrum is organised in order of decreasing wavelength and increasing frequency and energy. It is made up of a variety of different subsections of electromagnetic waves, including radio waves, microwaves, and the visible rays of light that we can see. Electromagnetic waves transfer energy from a source to an absorber, which makes them useful for different gadgets and devices. Here we can see they're used in radio transmissions, mobile phones, microwaves, TV remotes, infrared heat cameras, normal cameras, ultraviolet lights, X-ray images of inside the body, and gamma rays during medical treatments. Radio waves and microwaves are divided into bands of different ranges of wavelength, because the shorter the wavelength, the more information the wave can carry, but the shorter the range of this wavelength, and the less waves spread out. This means they have a variety of uses. Radio waves include frequencies ranging between 300,000 Hz to 3,000 million Hz. And radio waves are used to carry radio, TV, and mobile phone signals. They can be produced themselves or induced by oscillations in electrical currents. You can also use radio waves instead of cables to connect a computer to other devices, such as a printer, a computer mouse, or, for example, Bluetooth-enabled devices can communicate with each other over a range of about 10 meters without the need of cables. Microwaves have shorter wavelengths than radio waves, and people use microwaves for communications, for example in satellite TVs. This is because they can pass through the atmosphere and reach satellites above the Earth. Microwaves can also carry mobile phone signals. Microwave ovens are used to heat food faster than ordinary ovens. And this is because the microwaves can penetrate into food and are absorbed by the water molecules in the food and heat it. The oven itself does not absorb microwaves, as it does not contain any water molecules, and therefore does not become too hot, like a normal oven. Infrared radiation is emitted by all objects, and the hotter the object, the more infrared radiation it emits. Infrared radiation can be used in remote control handsets for TVs and video equipment, transmitting signals carried by infrared radiation. So when you press a button on the handset, it will send out a sequence of infrared pulses. The infrared radiation is used because suitable infrared pulses can be easily produced and detected electronically. Infrared radiation can also be used to heat up objects quickly. For example, electric heaters that emit infrared radiation can warm up rooms quickly, or electric cookers that have halogen hobs heat up food faster than ordinary hobs, and the use of halogen hobs are designed to emit much more infrared radiation than ordinary ones. You can further use infrared cameras to see people and objects in the dark. And finally, optical fibers in communication systems usually use infrared radiation instead of visible light. This is because infrared radiation is absorbed less than visible light in glass fibers. Some chemicals can emit light when they absorb ultraviolet light. Fluorescent chemicals are used to make posters and inks and security pen markers, seen here. Ultraviolet waves can also be absorbed by your skin, which can lead ultimately to damage, burns, or even killing of skin cells. But a use has been found by these ultraviolet waves in tanning salons, as tanning beds use UV lamps that give an artificial tan. X-rays and gamma rays Both travel straight into a substance and can pass through them if the substance is not too dense and not too thick. This is because they have short wavelengths and carry much more energy per second compared to the rest of the spectrum. Gamma rays can be used to kill harmful bacteria in food and on surgical instruments. About 20% of the world's food is lost through spoilage, mostly due to bacteria. Bacterial waste products cause food poisoning, and exposing food to gamma rays kills 99% of the disease-carrying organisms, including things like salmonella. And exposing surgical instruments in sealed plastic wrappers to gamma rays kills any bacteria on the instruments and helps stop the spread of infection in hospitals. Gamma rays have also been used in therapies to try and kill cancer cells. Doctors and medical physicists use gamma ray therapy to destroy cancerous tumours. A narrow beam of gamma rays from a radioactive source is directed at the tumour, and the beam is aimed at it from different directions to kill the tumour, but not the surrounding tissue. X-rays are often used to detect internal cracks in metal objects. This kind of application is possible because the more dense a substance is, the more X-rays it absorbs from an X-ray beam passing through it. X-rays are also used in medicine to create images of broken limbs. An X-ray can pass through soft tissue, but it will then be absorbed by bones and teeth or other metal objects that aren't too thin. The parts of the film or the detector that the X-rays then reach become darker than the other parts, so the bones appear lighter than the surrounding tissue. Furthermore, X-rays can be used to destroy cancerous tumours using high-energy X-rays, which have a shorter wavelength compared to those used in the imaging process we just discussed. Not all uses of the electromagnetic spectrum are free of different risks and dangers. For example, we said that ultraviolet waves can be used in tanning beds. However, too much exposure to ultraviolet waves can be harmful to your skin and cause burning or killing of the skin cells, and possibly even lead to mutations that trigger skin cancer. Too much ultraviolet radiation exposure to the human eye can also cause blindness. Ultraviolet radiation can naturally come from the sun. X-rays and gamma rays pass through a substance and can knock electrons out of the atoms in the substance. The atoms become charged, so they lose electrons, and this process is called ionization. If ionization happens to a living cell, it can damage or kill the cell, and for this reason, exposure to too much X-rays or gamma rays is dangerous and can actually cause gene mutation and trigger cancer progression. People who use equipment or substances that produce any form of ionizing radiation must wear a film badge, and the badge shows that it is overexposed to ionizing radiation. Its wearer is then not allowed to continue working with the equipment for a certain period of time. If you enjoyed this video, make sure you give it a like. And if you have any questions, leave a comment below. Check out more of our content and remember to subscribe to our channel.